Hi, Sai Krishna Rudru. How are you?
I'm good, sir. Thank you for asking.
Can you give your introduction to all of us?
Sure, sir. Sir, I am Sai Krishna Rudru. I'm from a town called Tanuku in the West Bengal district of Andhra Pradesh. I'm an electronics engineer. I did my graduation and schooling from the same in my locality only. After that, I started working in a IT company. Right now, I'm working in Hastin by Deloitte as a software development engineer in testing.
Okay. So, after your 12th class, why you choose electronics and telecommunication?
Basically, at that time, I was not completely sure about the branches and all. So I took some advices from my local people and who are all my seniors and all. They suggested me this electronics and communication and computer science. According to the rank I got this electronics and communication. So after that,
Okay.
I started working on the electronics communication. That is
According to
that.
your rank, you got EC. That means your first preference that time while counseling was not EC.
It's not completely like that. I have the same preference for both the things, but depends on the depending on the college, I got electronics.
Okay. Can you tell me roughly how many electronics engineers we have every year? How many electronics engineers are graduating?
There are like lakhs of people. I'm not
Lakhs
completely
means
sure.
1 lakh, 99 lakh, 0.1 lakh, how much?
So I'm not completely sure about the statistics of the how many people are graduating the.
Okay. So, what are the three qualities in you that is suitable for being an IAS officer?
So basically, I can do a like multitasking. I can do. Let's say currently I'm working in an IT company. Parallelly, I'm also preparing for the engineering services and all. So this multitasking I can do. This will be very helpful in the services also. And I am like so much of passionate about my work. Currently, I'm working in an IT company. I never took some advantage of the free time of my IT to prepare for this thing. I've separated everything. Like in my work time, I completely dedicated to my work only.
Okay. So, these are the qualities that are suitable for ESE officer, and you think that these are
And
you are
also, I can communicate with people very well.
okay.
I can interact with people.
Okay. That seems so. By your communication, it is looking like that only. Okay. And Krishna, what are the two qualities that you think that you are having those qualities, but that are not very suitable for being a IAS officer?
Uh, I'm not able to think of these things. I never thought of it. What will be my drawbacks in the services and all? Because I've never like I'm not completely sure about the work nature of the IAS officer. So I'm not completely sure about that at this position.
Okay. So you don't know much about the profile of a IAS officer.
I know about the profile about of an IAS officer, but when it comes to the real time working environment, it varies. What I read in the internet and all, it varies from that. So I
Okay.
cannot comment on this thing right now.
Suppose this time you are not able to make the result. So what will be your plan B? Are you continuing in your private sector job, or you'll try one more year?
So I'll be doing this parallelly, sir, because I am doing this job for my financial freedom.
Okay. So that means that you will be trying one more year.
Yes, sir. Yes, sir.
Okay. In the recent time, there is a meeting G20 summit.
Yes, sir.
What is the role of African nations in that G20 summit?
Sir, earlier this African Union was not introduced in the G20. This year, India brought up this African Union into a get into the G20 Union.
Okay. So what was the role this year? Yes, India Foreign Ministry have taken them as well. But what was their role? What was the significance?
Sorry, sir, I not sure about. I actually haven't referred this that much.
Okay. Thank you. Thank you, Krishna.
Thank you.
Yes, Rathi sir.
Krishna,
Yes, sir.
which are your favorite subjects?
Sir, my favorites are analog electronics, EDC, digital electronics.
And digital electronics. Okay.
Yes.
Now, what is the difference between software and hardware?
So basically, software runs on a hardware equipment. Basically, software we cannot touch. It's not physical. It is present in the form of the logic only. But hardware we can touch and we can make changes to that directly with our hands. It's physically present, that I can say. But software performs some actions using the hardware.
Can you give me the steps involved in IC manufacturing?
IC manufacturing. Sorry, sir, I'm not sure about this topic.
Okay. What is the difference between amplifier and power amplifier?
So power amplifier is a kind of an amplifier which amplifies both current and voltages.
Okay.
So amplifier, when it comes to a generic amplifier, it can be modifiable, whether it can be a voltage amplifier or a current amplifier. It's a generic version of an amplifier. Power amplifier is specific to increase the power strength of that device.
And what is the difference between amplifier and oscillator?
So amplifier it increases the strength of the signal given to it, but
Okay.
oscillator is something like which gives us some signal. Like it provides oscillations to us without any input. You can say that we have this DC power supply to it.
Okay. If suppose we want output without any input, then what should be the gain of the system?
Sorry, sir. I lost.
If we want to get output without any input, as you said in case of oscillator, then what should be the gain of system?
Gain. So gain should be high, basically.
High means
And
what?
high in the sense like it cannot go to saturation directly. If it go to saturation, it will be like at the same point. It should be in the range like within. We have this noise signal. From that noise signal, the oscillations get generated. So the gain should be in the mid range. I'm not able to tell you the exact figure right now.
Okay. You said me that now you are getting the output without any input.
Yes, sir.
Then gain
Yes.
should be what? Infinite. You heard about this?
Infinite means go to saturation. Yeah, it depends on the device, right, sir? Right.
In case of oscillator, we are using positive feedback or negative feedback.
So positive feedback, sir.
And what are the advantage and what are the disadvantages of positive feedback?
So basically, positive feedback increases the gain of like we can say the signal. It will increase the signal strength, like going on the time, and it goes to infinity. The output voltage will go to saturation state. And when we use this positive feedback, we'll get oscillations. Like if we provide any signal to the positive feedback amplifier, we cannot get exact output. Like some little changes there, the output will get saturated directly. This is one of the disadvantages of the positive feedback, and it is also increases the noise. Noise also increases in the positive feedback. I can think of these two things right now, sir.
Okay, so what are the advantages of negative feedback?
Sir, negative feedback decreases the gain, but the stability of the amplifier increases. And also, it increases the bandwidth, basically. We can use it for increasing the bandwidth. As the gain is decreasing, we can increase the bandwidth, as we know that the gain product is constant. When the gain is decreasing, the bandwidth obviously increases.
If suppose we are having the two devices, for example, one is what integrator by using op-amp, and second one is Schmitt trigger, that is multi-vibrator.
Yes, sir.
In which case we are having negative feedback, and in which case we are having positive feedback?
Sir, Schmitt trigger will be having a positive feedback.
Okay.
And the integrator, we can connect it as a Miller integrator. It would be like we can say it is a negative feedback device.
Negative feedback device. Why we are designing integrator by using op-amp?
Op-amp, we can design it using multiple ways, but op-amp we are using because of its high gain. High gain, sir.
Okay.
Gain.
You have used what that Miller.
Yes, sir. Miller.
Why it is called Miller integrator, and what is the use of that theorem, Miller theorem in integrator by using op-amp?
Sir, Miller is something like when a component is connected between the input and output. Like it's not grounded actually. It is connected between two terminals. Then it is called a Miller.
Okay.
So when it comes to Miller effect, it divides the actual value of the component connected between the two terminals.
Okay.
When it comes to the input side, the value of that thing decreases by some gain of that amplifier. I mean, whatever op amp we are using. When it goes to the output side, it obviously increases.
For every element?
No, sir. It varies for resistor and inductor. It will be of one case. For capacitor, of different case.
So in capacitor, it will
In
increase.
capacitor, at the input side, it will. At the input side, it will increase. Sir.
Last question. In case, can we design integrator by using passive RC circuit, low pass RC circuit?
We can use it for just normal testing purposes, but we cannot use it in the actual components because of the passive nature. Some leakages will be there.
Is there any other problem? What should be the value of resistor and capacitor if we want to design integrator by using RC circuit?
So resistor value should be very high because we cannot fabricate it using normal resistors in the actual circuit. It will occupy so much of space.
But it is very difficult to design high value of capacitor in case, or high value of resistor in case of IC fabrication.
Yes, sir.
And what should be the value of capacitor? High or low?
Capacitor value should be. It depends on the resistor value also, sir. If you want some kind of a RC value, so based on if you have resistor value of 10K, we want some particular frequency. So that capacitor value depends on these two values.
Okay, Aman sir, what?
Sai Krishna,
Yes, sir.
you said something about amplifiers. So in common emitter amplifier, can you explain me the role of emitter resistor?
So basically, this emitter resistor it provides a negative feedback internally. So it provides a stabilization to that biasing. When we want to provide biasing, it will provide the stabilization when we are using that. But because of the emitter resistor, the AC gain of the amplifier decreases. So that's why we use a bypass capacitor to bypass it during the AC analysis.
And why to connect and why to bypass it?
Sir, we want the stabilization for biasing. For that, we were using resistors. But when it comes to the AC thing, it is decreasing the gain. We are using this amplifier the purpose of the gain only. So as it is decreasing the gain, so we connect a capacitor to nullify that effect of decreasing the gain.
So you said stabilization of biasing, right?
I mean the biasing point, Q point.
So what do you mean by it?
So Q point is the point where the amplifier will be operated in a linear region. So basically, these BJTs are like a non-linear devices when we see the current and voltage relations. But when we operate this at a particular point, it will be operated in a linear. We call it a piecewise linear region. So we want to maintain this amplifier to be operated in that specific region. So that's why we use this biasing concept.
So why it is needed stabilization then? You are already operating at a fixed voltage and fixed current. Then
Sir,
why
due to some
stabilization?
So there are multiple factors that is affecting this biasing point.
What are
because
they?
of the temperature, the beta is like very sensitive to multiple environmental things. So we want to maintain that current relations. Like IB is also IB is also sensitive to temperature. Because of the temperature, these all values are changing. So we want to maintain the actual biasing point.
What is the relation of these points you said with the temperature?
As temperature increases,
can you quote any equation relating these terms?
There is one current called IC naught, reverse saturation current we call it. So it will be double for every 10 degrees raise in temperature.
Why it doubles? Why not 3 times?
So I'm not sure about this completely, but after some derivations and all, they come to know that it's doubling for every 10 degrees raise in temperature.
Okay. What should be the input impedance for a voltage amplifier? Should it be infinite, close to ideally, or should it be 0?
So for For a voltage amplifier, it should be close to infinite.
So do you know any example of voltage amplifier?
Voltage amplifier, we can use op amp as a voltage amplifier when we are using BJT or MOSFET. We have this CC, sorry, common base amplifier is a voltage amplifier.
So what is the input impedance of common base amplifier?
Oh, sorry, I just got confused about it. So basically, this common collector have a very high input impedance.
So is
For a
common
voltage
collector a
amplifier, no, sir. It's a current amplifier basically. The requirement is like for a voltage amplifier, input impedance should be high, output impedance should be low. But when it comes to CC and CB, common collector and common base, common collector is having high input impedance, but output impedance is not low.
Common collector output impedance is not low or low? Yes, let me clarify. You are getting.
Yes.
Let me clarify.
Yes.
CC, common collector, is a voltage amplifier or current amplifier?
Current amplifier.
Input impedance of CC is high or low?
High, sir. High.
How it is? It is having like voltage amplifier. You said input impedance is high, but it is acting like a current amplifier. How do you justify this?
Based on the current relations at the input and output side, we can calculate the input impedance, output impedance. From that, I can define this input impedance is high, output impedance is low. Such kind of list I can bring on. But practically, you want me to say, I'm confused over there.
Okay, coming back to EDC, because you mentioned EDC as well.
Yes, sir. Yes.
You tell me what is donor energy level?
So donor energy, when we dope a semiconductor, there are like temporary energy levels are formed below the valence band.
Why only below the valence band? Why not above or why not?
Sorry, that below the conduction band.
Why not below conduction? Why only below conduction band? Why not above?
Sir, we are adding impurities to the semiconductor. That means the resistance of the complete thing increases. So if you want to have the energy level above the conduction band, its resistance should be decreased. I mean, like the potential we should give to move an electron from a valence band to conduction band should like it should be zero. I can say if it is in the above the conduction band. Like we don't need to give any energy to it to move that to have that charge carrier to be conducting in the current, participate in the current flow.
It's not exactly to answer my question. I asked why donor energy level is close to this. Why not above or below?
Why above? Why not above or below? Sir, because we are adding the impurities which are having the molecular size very near to the actual size of the our semiconductor. So we are adding the donor impurities, they are having extra electron. So electrons will be staying near above the conduction band. They will be conducting.
Example of donor impurity.
Donor impurity, phosphorus.
How many electrons in the outermost?
5.
Why only 5 outermost electron atom to be added? Why not 7?
Sir, as I told, like the atomic size should be fitting in between the whatever the semiconductor we have. Those should be like near to that. It should occupy the interstitial positions. If we use a 7th group or any other group element, it won't fit in that specific place. So it will automatically increase that resistance of that specific thing. We cannot have control over the charge carriers in that case.
What is the size of the pentavalent atom? What is the size of silicon atom? Because you are saying it is because of size.
So they are very near to that size of the silicon.
How much? How do you measure?
We based on this what we call mass and atomic weight of we can in the periodic table it is all mentioned. From that we can get the what are all the things we can use for donor impurity.
Last question. What is Fermi energy level and what is the significance of it in semiconductor devices? Sir,
Fermi energy level is the energy level where the probability of occupying an electron is 1/2. half.
Okay, what is the significance of it?
So
Why
Fermi
do we need
energy,
why do we need Fermi energy levels?
uh, why do we need Fermi energy? Sorry, sir, I'm not able to recall this one.
Oh, okay. Over to you, Rakesh.
Hi, Sai Krishna.
Hi, sir. Good afternoon.
You have operated any calculator anytime? Be it scientific
Yes.
calculator or even a regular calculator.
Yes, sir, I operated.
Let us say we enter any two number, 45 and 36. Okay. What is the addition of these two displayed on the screen of calculator?
45 and other number?
36. 36.
30. 36. 30. Yes, sir, sorry. It's 81.
Fine. But when you are entering into the calculator, you are entering decimal 45 and decimal 36.
Yes,
It
sir.
is the correct answer 81, I agree. But
Yes, sir.
internally, what is the calculation inside the calculator?
So it's binary.
Okay. So now, if you add 45 and 36 in binary, or do it in hexadecimal, okay, will it be really 81?
Oh, no, sir. It will change based on the number system we are implementing in that calculator design.
What is the number system expected in a calculator? Although I have taken positive numbers, okay, but still tell me what is the number system implemented inside the calculator? If you take sine.
Sir, I feel they were using normal binary only. I'm not completely sure about it. But if we use hexadecimal, there are some points where some values where we won't use directly in the real world.
Can you recall any algorithm how the correct answer is displayed in decimal?
Decimal.
You can to any command of microprocessor, any of the microprocessor you know, maybe 85 or 8, maybe 86.
Command to convert a number into decimal.
We all know everybody knows 81 is the answer, but how that is happening, because what we are entering and what we are seeing is decimal, but internally what is happening is binary. And if you add 4, 5 and 3, 6, write down in 4, 4-bit binary, it will not be 81.
Yes, sir. Yes, sir. Yes, sir. There is one command I recall, decimal adjust after addition.
Decimal adjust accumulator, DA.
Accumulator, yeah, DA. Sorry.
Okay, got it. Suppose now you have used scientific calculator now.
Yes, sir.
Suppose your 81 ko hi le lete hain. Suppose now minus 81 I want to display. Okay. And in the scientific calculator you have the base also, na? Binary also you can display, decimal also.
Yes, sir. Yes, sir. We can.
You have used that feature sometime?
Okay. Yes, sir.
Okay. Suppose I want to enter minus 81 as a decimal number now. Okay. Then convert to binary. What will be on the screen of the calculator?
The value of the minus 81.
I convert to binary. I give the binary mode into the scientific calculator. What will be there on the screen of the calculator?
The first digit will be 1. I have not converted this into binary for a negative number, but when we convert a minus 8 negative number into binary, the first digit will be 1, which represents the sign of the number. Then depending on
either tell me what is the answer on the screen or either tell me the algorithm. If you have pen and paper, please feel free to use it.
Algorithm, I'm not able to recall, sir. I heard of this algorithm, but I'm not able to recall this actual name.
Chalo, theek hai. Then let's switch to another question.
Yes.
You have pen and paper?
Yes, sir, I have.
Take a 2:1 multiplexer.
Okay, sir. 2:1 multiplexer.
Okay. Onto the select line, I apply clock signal.
Okay, sir.
Onto the I0.
Okay, I0.
Onto the I0, connect the output of the multiplexer itself.
Okay, output of the multiplexer, yes.
And onto the I1, connect some external input, suppose X.
Okay, sir, X.
What is the circuit equivalent to?
Based on the clock, it will operate.
On the select line, it is clock. On the I0, it is the output of multiplexer itself. Feedback path is there. And onto the I1, external input is there, X.
Okay. So I'm referring to the initial value of the output of the multiplexer is 0. Okay. So 0 will be turning there for every term.
I want to know what this circuit is equivalent to,
Okay, equivalent to.
what it is actually performing.
Whenever the clock goes high, the output will be the X value we are getting. You want me to tell the exact equivalent name of this circuit?
Exact, yeah, at least some hint you can.
I mean,
if clock is 0, what is the output?
sir, it's like clock is the previous output only.
And if the clock is 1?
The whatever the output is coming from the X value.
Okay, now what it is? Everything is in front of you.
Yes, sir. If it is a one, it's like a normal D flip flop. Whatever coming here, it is just coming out of the.
Now, is it a D flip flop or D latch?
Okay, sir. D latch, because there is no memory here.
D flip flop or D latch? Come again.
D latch, sir. D latch.
So, what is this difference between the latch and flip flop?
The flip flop will have some memory.
Okay.
It can hold the previous state.
This also has the memory. I mean, even latch is also a memory device only.
Yes, sir. But it's as it is a clocked one, we can say it as a flip flop. If there is no clock, then we can say it as a latch.
Sure? No.
Okay. I can remember like clock or latch is called a flip flop.
This is a latch only. It's not a flip flop. It's a D latch because it is working on the level of the clock. The answer is with respect to level triggered or edge triggered.
Yes, sir. It's a level trigger one basically. I can.
So, can you explain me race around condition?
So race around condition comes in this thing called JK flip flop. Here what is happening is during the because of the clock pulse width, when the input is 1 1, the output is completely toggling during that period of the clock. This is called race around condition.
Okay.
And to avoid this, we have like a few things. One is we can use master slave connection. Other we can have the condition of the propagation time should be greater than the pulse width of the clock.
What is this master slave configuration?
So master slave configuration, like two JK flips are connected together with the clock connection is like one is for the first one, the clock will be given directly. The second one will be the inversion of the.
Why
clock.
somebody is known as master? Why somebody is known as slave there?
The first one will be called as a slave. So here one of the flip flop is like having the race around condition, but the other flip flop is not allowing it to go into the output. So the flip flop which is having this race around condition is called as a slave, and master is controlling whether we have to transport it to the output state or not.
Okay. And suppose I give you an array of, let's say, n bulbs. Let's say 10 bulbs. There are 10 LED bulbs. Okay, 10 LED bulbs. Okay. I want to glow only one bulb at a time periodically. Okay, let's say 1 second. Let's say the period as 1 second. Okay, at the next second bulb will go. At the third bulb will glow. Only one bulb at a time. Okay. Sometimes you see in Diwali and all such lightning patterns.
Yes, sir. Yes, sir. Yes.
So, how can I implement this? What type of counter can I use it? Yeah, what type of, if not counter, what type of circuit you can suggest? It can be any number of bulbs. Suppose I say 10 bulbs are there. Only one bulb should glow at a time periodically. After 1 second. After another second, automatically it should keep running.
Sir, we can use a decade counter connected to a what we call encoder or decoder. We can connect it to an encoder.
Okay.
We can use a decode counter, which output will be connected to the input of a encoder. So based on the output we are getting at the counter, the specific output will be selected at the where the bulbs are connected.
Sure, it will be encoder.
Yes, sir, it's an encoder because we want to have like 10 outputs.
Forget. Any direct counter can you use here? Any famous direct counter without using any other extra hardware?
Famous counter. We want 10 bulbs to be.
What about ring counter?
So, but ring counter, we need to have like a size should increase. It will be increasing there for the ring counter.
That's okay. There is
If
no
that is the case,
there is no constraint of size from my side. I only want
so
to
that's how that then we can use our ring counter, because if we have 10, we need a 10-bit ring counter for each and every output of that specific bit. We can connect a bulb.
Okay, I'm done.
Okay, Krishna, your interview is now over.
Oh,
Now we are coming to the feedback part. Before we give you the feedback, can you tell me that how you think your interview gone? According to your expectation, it is average, good.
yes, sir. It's below average because I couldn't prepare much on the technical part at this point of time.
Okay.
So I need to focus more on the technical part and the national and international affairs also, like how they are affecting our country. That also I need to report.
Okay. What according to you think that what should be the marks you got now? Then that marks will be how much percentage of those marks will be depending on your technical skills?
Sir, I feel like 60% from my technical, 40% from the general part that will be asked by the chairman, sir.
Okay. Okay, Krishna, let me tell you now. Actually, the marks depending upon your answer is not 100. Technical plus non-technical itself is not 100. That is only 50 to 55%. Okay, whatever the ratio may be of technical, non-technical. 45% depends on your way of handling the interview, your way of giving the answer, rather than the final answer, how you are giving the answer. Might be sometimes sir is asking a question. You know the answer. You say like this. Your answer is like this. Okay, so what that 45% depends on that as well. Krishna, are you going to wear the same outfit in the?
No, sir. I'm going to wear a blazer and with a tie and all.
Okay, so that will be good. Technical feedback sirs can give you, but as per me now, what I feel that sometimes you are giving the answer very fast. Might be you're knowing this, not knowing this, or your speed of giving the answer can be little bit reduced. That will make your answer more effective. Okay, because certain time what happened, you said something, then no, this will be the answer. Might be if you're going with a slower pace, instead of reframing, in the first attempt you can frame the best option.
Yes.
Okay, I am again telling you, technical plus non-technical answer is only 55%. 45% is your way of answers. Okay, and sometimes not at all of your answers, but at sometimes what I feel that your way of answering is not perfectly formal. As initially, I feel that it is not like looking like you are giving the answers to a UPSC panel or UPSC board members. That is why ना when you said that कि आप बात करते, मैंने कहा हाँ वो आपकी बातों से लग भी रहा है that ऐसा कुछ conversation हमारा हुआ था. I'm forgetting that कि हाँ आपकी बातों से लग रहा है कि आपके दोस्त बनते होंगे ऐसा कुछ. Okay, so थोड़ा सा ज्यादा formal होगा तो ज्यादा अच्छा रहेगा, है ना? बाकी टेक्निकल को बता देंगे. Sir.
Valid points, Sai Krishna. You should take from Abhinav sir about the things what he mentioned is very, very important. Like one is control on your expressions and control on the flow you have. That is, and another is more formal. It should be more formal.
Yes, got it.
I think since you are in IT industry so far, maybe informal ho gaya thoda.
Yes, sir, kind of. Maybe.
Try to come back to formal way.
Yes, sir, I will try to control my
panel. Maybe expecting that. So let's not take a chance there. So try to be more formal. Your attire and your presentation, everything should be formal.
Yes.
Coming to the technical part, you're okay, not bad, and you're better. I don't say best it is. Because some of the questions you don't know the answer, but you are trying to make up the answers. If you don't know, honestly say that it is not under my limits or not aware, but most of the things you said correct only. So I say 60-65% of the answers are to the point, but not exactly to the 100% answers there. So if you have, when is your final interview?
So it's on November 3rd, the last day.
So still you have time. So focus more on the concepts well. And second, as you said, you also agree that the recent current affairs also you have to be thorough with, because there are questions expected there also. So don't be in a hurry to move here and there. Focus on the answers and controlled answers, formal and controlled answers. So that's from my side.
Thank you, sir.
Rakesh sir and Sanjay sir, you want to add anything?
Also, same thing. First of all, listen carefully what we are saying, okay? And suppose you are using one word, that Miller.
Miller,
It is a
yes.
new word. Definitely they will ask question on this type of questions. Suppose we are using some words, then if you have confidence on that, I can explain that word, then use that word. Otherwise, no need to use this type of word. Because I have simply asked what is integrator. If suppose you are not using the word, I'm not having any question related to what Miller's theorem and so on. Once you have used this word. Second thing, you are from software, right? But
Yes,
you
sir.
are saying that your favorite subject is electronics and what digital. And we
Yes,
are
sir.
finding application in hardware industries. Then what
Yes,
are the challenges and were faced by what hardware in India, and what is the future of hardware, right? Because number of companies are now these days are coming
Yes, sir.
on IC manufacturing. No? Please prepare all those points. And
Okay, sir.
simple, I have asked one very basic question: IC manufacturing. What
Yes,
are
sir.
the steps involved, oxidation and so on for the synthesis?
Yes, sir.
You get the idea about that. Because
Yes,
you are in software now. What about the iPhone 15? Launched on that 12th of
Yes,
September.
sir.
It is what made in India. Mainly what
Yes, sir. Made in India.
that definitely they will ask question on hardware, right? So please prepare all
Okay,
those.
sir.
Yeah, again, coming to the digital part also, I just suggest just brush it up once again, because at some
Okay,
point,
sir.
at some points you were not able to recall the concepts. So
Yes.
you knew it is understand if you take more time, you'll be able to answer it, but you will not have that much of bandwidth. And you mentioned it as one of your favorite subjects. That's why I'm suggesting.
Okay, sir.
Let's talk 2 or 3 favorites, at least be well prepared about that.
Okay, sir.
Okay. Sai Krishna, आपको एक mail आएगा. You'll get a mail.
Okay.
Please acknowledge that mail. Then you'll be getting the video, this raw video of this interview.
Okay, sir.
After your acknowledgement. Okay.
Okay, sir.
Okay, and your marks will be given by the team members with whom you are in contact now. They will give you the marks as well. You can ask them.
Okay, sir. Okay.
Okay.
So
Any
I
questions
have,
from your side? Yes.
yes, sir. Like I'm a PWD candidate right now.
Okay.
So for the PWD candidate, so I need to prepare for this PWD ministry. What are the schemes that PWD people are having right now?
What are the? Come again. What are the?
What are the schemes we are having specifically for the PWD candidates, reservations and all?
Okay, you can have them, but most probably they will not be asking this. But
Okay.
even the interview has no syllabus, na?
Yes, sir.
So they can ask, but most of the times they will not be asking this. But if they ask, you should be prepared.
Okay.
In your earlier stages, when you're given the examination, then you are up to all, you reached to the interview level as well?
No, sir. This is my first interview.
Okay. So usually they will not ask this, but if they ask this, then you can prepare.
Okay, sir.
Any other question?
No, that's all from my side.
Okay. Thank you.
All the best.
Thanks. Thank you, sir. Thank you.